Hi, welcome to the Unit 10 System of Linear and Inequalities video. Um, Today we're going to be talking about systems of linear inequalities, which are basically the exact same thing from our previous video on graphing linear inequalities, but now we have a system. And a system just means we have more than one. We could have one, we could have two, three, maybe even four, depending on what kind of problem we're working on. The thing that you need to keep in mind is systems of inequalities has a lot of traits that systems of equations has, where when systems of equations are answers where the lines intersected or touched. Well, here, when we were doing linear inequalities, our answer wasn't necessarily the line as much as the shading. So when we do systems, we want to know basically the solution is when the overlapping shaded regions happen, so where the shadings touch. So to find this region, we're going to first solve all of our equations for y, find the m and the b, and then use those to make the graphs. Make sure you pay attention to the dotted lines and the solid lines. Remember, dotted lines come from less thans or greater thans, or I guess greater thans and less thans, and then greater than or equal to's and less than or equal to's are the solid lines. Okay, and then you're going to shade each inequality in the proper direction. Greater thans go up, less thans go down, unless you have an x equals line, and then less than goes to the left, greater than goes to the right. Okay, um, and then when you have the overlapping region, make sure you understand that that needs to be the darker one, because that's actually only the answer. Okay, you'll have three regions or sections of the graphs colored in, but the dark section is the part that's the actual answer set. Okay, and just make sure we know when you show us the answer that that is your answer in some way, shape, or form. Okay, so there's the possible solutions are you do have intersecting regions and you've shaded them in darker, or the possibility, which only happens with parallel lines, um, that you have a no solution where none of the regions intersect. And I'm not saying that all parallel lines will create no solution, but what I'm saying is when you have parallel lines, that has the possibility of having no solution. There are three other cases in there where you could have a solution when you have parallel lines. Okay? So let's look at our first example. Um, the first step is to make sure you have all your equations solved for y. So um, in my yellow equation here, it's already solved for y. But you'll look at my pink equation here, and it's not. So we need to go ahead and solve that one for y. So I'm going to take my negative 3y is less than x minus 6, and I'm going to solve it for y. Well, to get y by itself, I need to divide by this negative 3. So I divide by negative 3 to each thing. Okay? Well, negative 3 divided by negative 3 gives me 1, and y is going to come down. Technically, this is 1x, and it won't divide evenly, so it becomes negative 1/3 x, and then a negative and a negative make a positive 2. And then the key here is to remember that when you divide everything or all sides by a negative, the sign will actually change directions, okay? Leaving us with this equation, or inequality, excuse me. And so this will be my new pink line, okay? So, or my red line. So now I'm going to go and I'm going to draw my equation, or my inequalities on the graph. So I'm going to start with the yellow line, and I'm actually going to do this in green. So, and then it will be a dotted line, okay? But we're going to start at 1, alright? And then this says negative 1/3. is my slope, okay? And so with my m being negative 1/3, that means I'm going to go down 1, right 3. We always go to the right. I don't care if it's negative or positive. Just go to the right to start. And then you can backtrack later if you need to. And then my b, we said was 1. Okay? So, so now I'm going to go down 1, right 3. Down 1, right 3. Down 1, right 3. And I ran out of room. Okay, and so now I'm going to backtrack. I'm going to go up 1, left 3, 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 up 1, left 3. Okay, there I go 4, I did. Up 1, left 3. There we go. And then up 1, left 3. Having some issues with my pen here. Okay, so then you want to draw that, and like I said before, it's a dotted line because it has a no equals to on it. Okay, and then let me back that up because it was not dotted. There we go. Okay, and then it says the y's are less than, so we're going to shade down. So this is where I bring in the yellow highlight. Down. If you're struggling on where to shade, you can refer back to the first video that we had on shading. But make sure you shade everything that's below that line. Okay? And then keep in mind that it's a dotted line, so any point that's on that line will not count as a solution because dotted lines, the solution can't be on them. Okay? So now we're going to look back at the pink line, and our m in this case is negative 1/3. Notice how it's the same slope as the one before, which means we're going to have a parallel line since our y-intercept is different. Okay, um, I'm going to draw this one in red since that matches more of our color. And we're going to begin at 2, so I'm going to go up to 2. And then we're going to go down, down 1, right 3, down 1, right 3, down 1, right 3. And then we're going to backtrack up 1, left 3, up 1, left 3, up 1, left 3, up 1, left 3. And basically, you're one dot above all the other dots. Okay? And then I'm going to go draw my line. This one is also a dotted line. Okay? And so now I have that. And if you'll look, this one has the y's are greater. Okay? Greater things go up because we're basing it off of y. So this is the greater side. So now, remember before we talked about there was a possibility where there was no overlap, and notice how there's a gap here in the middle. We had parallel lines, and these did not overlap. Okay, so this would be an example where there is no solution. So no solution. Okay, because there's no point that we can do that will satisfy both equations. Okay. Um, Again, we could have had the top one shaded down and then the overlapped region would be here, or the bottom one would be shaded up and the overlapped region was here. We could have the top one shaded down and the bottom one shaded up at the same time, and the overlap region would have been in the middle. But in this particular case, they shaded away from each other, leaving a gap in the middle, which means that there was no solution. Okay, so now you can pause the video and work on example 2 on your own, and then unpause the video, and the whole solution will be on the screen, and you can just double check your answer and then move on to example 3. Okay, welcome back. We found that our slope for the first red line was -1, and that's the same thing as -1 over 1. Um, I shaded this one with pink, and I shaded the bottom one with blue, and then I found that the slope for the bottom one was 1 or 1 over 1. The y-intercept for the top one was 2, and the y-intercept for the bottom one was 4. Okay, and so I graphed them. Notice how I used dotted lines because these did not have equals 2's on them. And then for the pink line, I shaded down. Notice how I shaded all the way down below it. You may want to take your piece of paper and cover up the side that is not the left-hand side and shade everything that's not covered up by your piece of paper. And then do the same thing for the blue line. Notice how it's greater than, so I shaded up and cover up the whole bottom side and shade everything that way. And then you'll notice that we have a purple area right here, because what do blue and pink make? They make purple. So this is our answer zone. Okay, anything inside this region is the shaded region or the answer set. Okay, so all of our answers lie in here. Um, so some examples of solutions would be this point right here, which if you'll count 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, so it'd be the -7, 3 is a solution. Okay, um, this point right here where they intersect at -1, 3, this is not a solution. Yes, it is on both lines, but since they're both dotted, even if one of them was dotted, if you're on a dotted line, it is not a solution. Okay, other examples are not a solution would be right here at 3, 1. Okay, um, over here at -2, -2. And then up here, let's call that, let's see, 1, 3, 4, 5, 6, 7 at 1, 7. Okay, so these areas right here, not a solution at all. This one, not a solution. But anything in here, a solution. Okay, like 7, 7 right here, solution. So move to example 3, and in this question, we'll notice that these are not set equal to y. So I'm going to have to solve each of them for y. So this is kind of like your refresher on solving for y. So the first thing I want to do is move my x term to the other side. So I move 4x to the other side. And basically, whatever it is on this side, it'll just be the opposite over here, but we'll write it algebraically. Don't forget to bring down your negative with the 3y. And then it's -4x plus 9, because it was a positive 9. We'll divide by -3 to each side. Make sure you remember that when you divide by a negative, you must flip the sign, the inequality. And a negative and a negative make a positive 4 over 3x. And positive and a negative make a -3. Okay? So this is my first equation. It has an m of 4/3 and a b of -3. This means we're going to go up 4 and to the right 3. Okay? And so I'm going to go ahead and make this graph. So I'm going to start down here at negative 3. And then we're going to go up 4, 1, 2, 3, 4, 1, 2, 3. Make sure you start from the point you made. Don't try to start from 0. Okay? And then we're going to go 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay? And then now I have a tool that I can use to draw the line. So I'm going to utilize that. And just make sure you go through the middle of all your points. And notice how I made a dotted line because this has no equals to in it. Okay? So now for my red line, um, I'm going to solve it for y. 2y minus x is less than negative 6. So I'm solving for y, so I need to move my x term to the other side. So I'm going to add x to the other side. And then that's going to give me 0. 2y will come down. It'll still be less than because we didn't divide by a negative. So we got x minus 6. And now I'm going to divide by 2 to both sides. And so then I'm going to end up with y is less than, because we didn't divide by a negative, and then that's really an understood 1 right there. And so you got 1 half x and then negative 3. So we're going to start down at negative 3 also, right here. And then we're going to go up 1 over 2, 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 and then you would repeat the other side. Um, but I've got a tool that'll draw a straight line for me. And so as long as I line it up fairly good, I get a good solid straight line. Alright, and now for shading. Okay, so make sure you don't go to the original. You stick with where you were to begin with. So this is where my y's are greater. So for the blue line up here, that's the greater side. So I'm going to shade on this side. Notice how I go through the whole other equation. I don't use that as a blocker or anything like that. I shade this whole side of the blue line. Okay? Everything. Okay? Now for my red line, we want the y's that are less than. So y's that are less than. Okay? So I'm going to shade on this side of my red line. Everything down here. Okay? And so you should see in the overlapped region that my overlap region is right in this little V. Okay, I'm just darkening it up so that you can see that it's the purple region right here. Okay, and so my answer will actually come from this spot right here. Okay, this is my answer. Technically, you don't have to color in the other sides. You only have to color in this region. So if you're really, really good at it, you could do that. I at least encourage you to lightly shade with a pencil or something and then color this in if that's what you would like to do, just so that you get the habit for it. Okay? Um, so you can now pause the video and move on to example 4. This one's got those special case ones here. So I really want you guys to try. You should know how to do this. So just pause the video now, and then the answer will pop up. So this is your answer. Remember, the x lines are the extreme slope lines, and so you'll have that vertical line, y lines. Why would you go skiing on a flat slope like this? Notice how the y one's dotted and the x one is solid because the x one has that equals to underneath. Um, Greater x's, so you had to use the x right here as the greater one. This is where you were focused on that one. With the y's, you're focused up here and here. And since they were both greater, we use this is the greater y, this is the greater x. And then when they overlapped here. So this is the answer. So if that part of your graph isn't shaded, and like maybe this one's shaded or this one's shaded, then you're wrong. Okay? Make sure that this is the main shaded area, okay, and everybody knows that that's your solution. And anything that falls in here, any point in here is the answer, and any point out here, not the answer. And then I ask you, is this a solution? Yes or no? The answer is no, because this one is dashed, and dashed lines can't have a point on it. If they had both been solid, yes, but since one of them was dashed, automatically not an answer. Example 5. This is where we step it up. We have 3 inequalities now. Okay? Make sure they're all solved for y. Well, this one is, but this one is not. So we need to solve it for y really quick. Okay? So we have y over here, and I want it over here. Okay? So I'm actually going to add y to this side because it's a negative, and I don't like to have negative y's. Okay? So now I have y minus x is less than 4. And now I'm going to add x to this side and add x to this side because I want to get rid of the negative x, or it's always the opposite when it's on the other side, and you get x plus 4. So now I have my red equation. Um, my blue equation will be this one. And let's go green. We'll go green with this guy right here. Okay? So red's here. I make my dot. So start at 4, 1, 2, 3, 4, and then it's a slope of 1. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, since it's a dotted line, I'll probably just leave it like this because I've pretty much dotted all the way across. You can make the little arrow at the end if you'd like. Maybe you go through and connect a couple dots here and here. Um, a tip, if you ever forget to make it dotted and you went ahead and made it solid, what I would do is just leave your line there, but make like, I would just bold out the dashes in it, okay, so that it looks like a dash, or you could go through and just erase sections into it. Don't erase your whole line, okay, because I'm notorious for forgetting to put a dash line in there, okay. So for my blue line, my slope is also 1, or 1 over 1, and b is my negative 6. Okay, so I'm going to go down 1, 2, 3, 4, 5, 6, make a dot, and then I'm going to go up 1 over 1, like this. Okay, and then this one is a solid line. Okay, um, because it has an equals to. So we'll go through and make this look nice and clean. Okay, and then we have our last line, our green line. Um, these are y equals lines, so they're flat. Why would you go skiing there? And then I do it at negative 2. So I go negative 2, and then you follow this grid line going all the way across. Since I do it with the tool, I have to start at the end, so that's why I do it there. Okay, now it's on to shading. Okay, so with my red line right here, we're going to use this. Y is going to be our reference point. So I'm looking at the top and the bottom, and it's the less than line, so that's right there. So with my red line, I follow the line all the way up as best I can, and I shade everything in this half of the graph or whatever. Wherever that line is, I shade everything below it because it's everything that's less than that. Okay? So now I go to my blue line. Okay? Make sure we know that. Okay. The blue line right here, we're still referencing the y's, and we want the y's that are greater. So I'm going to shade up here. everything. Notice how I didn't stop at the red dashed line, like I kept going through it, even though it was there, and then I color in everything here. So now you'll see that my solution is going to be between these two lines. But it's not everything between the two lines, because we have this third guy right here, okay? And it wants the y's to be the reference as well, but it wants the y's at the bottom. So now I follow this all the way across, and then I shade here, okay? And so we have all these different overlappings, but where did we have all three of them overlap? Okay? So what was my true overlap region where red, blue, and green all overlapped? And that is this area right here. Okay? This zone, this is the solution zone. Okay? That's the answer. So anything that falls inside this region is a solution. Now, if it falls on this line or this line, it's a solution. But once it starts touching the dotted line, so right in here and this little corner, anything on this line and this corner, not a solution because it's a dashed line. But solid line, all of these points right here on the line are solutions, and anything in here is a solution. But everything out there, not solution. So you can pause the video, answer question 5. Answer example 6 on your own. The answer will pop up momentarily. Okay, so the answer to example 6 is this triangular shaded region right here. Remember, dotted line on this one. In this case, anything that's on these lines are solutions because they're both solid lines. And then anything in this region solution, anything outside of this region, all the way around it, not a solution. Okay? If you have any questions, please find a tutor or Miss Porter, and have a nice day.